equation. Solve each equation using algebraic methods. It means just don't graph it and see where they're equal to. I know you can do that, but we are going to do it algebraically. Okay, just like you'd be able to do on your test. On number 1, log base 5x plus 3 is equal to 1 minus log base 5x minus 1. As you look at this problem, you should notice a couple things. Log base 5, and a number. So what's going to be the best approach here? You can do it lots of different ways, but what's going to be the best approach? Alex? Put all the logs on the same side. You don't have to do that, but it makes it a lot easier. So it's log base 5, and then I'm going to have x plus 3, and then I move this over, so it's going to be plus log base 5 of x minus 1 is all equal to 1. Now that I got the logs on the same side, Jake, what am I going to do next? Combine them. So what am I going to do with the two things? I'll multiply them. So it's x plus 3 times x minus 1 is all equal to 1. I've done that. Then what, Chris? The opposite of factor. FOIL. Yeah, you're good. How do I get rid of log base 5?
5 to the power of 5.
Yep, base of 5 here on both sides. That's going to cancel. Chris is right. We could go ahead and FOIL them if you don't believe me. Get better at FOILing, but it's x squared plus 2x minus 3 is all equal to 5 because it's 5 to the first power. It's a quadratic. So if it's a quadratic, I want it to be all equal to 0. So I'm going to subtract that 5 over. Then I'm going to factor. Two numbers that multiply to get me 8. Let's go 4 and 2. And they add to get positive 2. So positive. Positive 4 and negative 2. So x is 4. I'm sorry, x is negative 4. And x is a positive 2. Which answer do I actually want here? Just 2. Because if I took negative 4 and I would plug it right back in right there or right there, I'm going to get a negative argument. And I can't have a negative argument or even a 0 argument on logs. Make sense on the first one?
Yeah.
All right. Let's do the second one. 2 to the x plus 2 is equal to 3 to the negative 1/2 x. So this is a little bit trickier one. I'm trying to get x by itself. And so to start off here, what can I do? I'm going to do a log. Log base what do you want to do here? Let's do log base 2, just because that's a little bit more complicated. So we're going to take log base 2 on both sides. On this side, it's easy. It's going to cancel. It leaves me with just x plus 2. On this side, it doesn't cancel. It's log base 2 of 3. Remember, that's just a number. And if I'm taking the log of this, remember what we can do with that is we can take this exponent and put it out in front. And so it's going to be negative 1/2 x log base 2 of 3. Okay, we did that. Again, the key to this problem is this is a number. So in my calculator, I'm going to take alpha f2 log base 2 of 3. That's my numbers. I'm going to hit enter. It's that number, 1.58496, blah, 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 blah. What do I need to do with that number? I got that negative 1/2, so I'm going to multiply that together. So I'm going to say times negative 1/2, so negative 0.5. So it's negative 0.792. I'm going to round it on my paper, even though I'm not going to round it in my calculator. It's that. Still need to get x by itself, so I need to get all the x's on the same side. So I'm going to subtract x. Subtract x. So it's 2 is equal to negative 0.792 minus another x is going to get me negative 1.792x. In other words, I'm just taking that thing minus 1. It gets me there. If I want to get x by itself, then I need to divide by that number. So I'm dividing this by this negative 1.792 number. That's what's going to get me x by itself. So in my calculator, I'm taking 2 divided by that thing right there. Hit enter, negative 1.116. Questions there? I'm getting one. All right, here we go. Today, we are talking about That was my drawing at Eli. It's going to be way better here in a second. All right, today we're talking about banks, and we're going to understand how exponential equations relate to banks. Okay, probably one of the more important lessons I do because it's something you're actually going to use and maybe help you understand life a little bit better. I would say the number one thing that I was mistaken about when I was in high school is I misunderstood what a bank was. Okay, when you talk about banks, I used to think, hey, bank is a government entity like the fire department, okay, or the post office, and they were there to help me out. And that's not what a bank is. A bank is a business. Okay, first and foremost, it is a business. There's a reason why some of the wealthiest people in the world run banks. Okay, because they make money. That's their goal. Okay, not anything beyond that. Besides, that's what their goal is to make money. And so we need to understand what that happens with, how that happens. Okay, so this is Chris. Chris, how much money you got to put in the bank right now? How many hypothetical? $1 billion. How about we go with $1 million because I don't want to write all those zeros. All right, so $1 million. Chris is going to put his money in the bank account. Okay, and there's a couple of reasons why you want to put money in the bank. Okay, one is it protects your money. Okay, it's a place for it to live instead of underneath your mattress or buried in the backyard. It's going to give you a place to soundly keep your money. The second reason is it gives you access to that money if you're in a different place. If you aren't actually buy your money, you can have access to it. Okay, the Chase Bank, they're everywhere. So you can have that access, whether it's through a debit card or through digital stuff now, it gives you that access. The third reason is they want to have your money because it is a business. That's how they work, is having that money. And we'll explain that here in a second. Okay, but Chris is putting his money in. For this situation, it's one person, but it's not really one person. It's everybody puts their money in the bank. So they have a collective pool. Okay. Who wants to buy a car? All right. All right. Annika's closer. You're back there. And I haven't gotten a draw. That's Annika. How nice of a car are you buying? A very nice car, like $1,000 Bugatti. I don't know how much Bugattis are. I'm sure they're expensive. Probably more than $100,000. Yeah, we're gonna go with 100,000. I'm bad at math sometimes, so we're gonna keep it easy. $100,000. So she needs this nice car. She's got to have it right now. She doesn't have $100,000, and because of that, she knows she can get that money from the bank. But they're doing her a favor, right? She doesn't have that money. They're going to give her that money. And because of that, Annika's very happy. She's got her car. She's excited about it. She needs it. She's got it. But because of that, it's like she's paying a tip back. Okay, she got that $100,000, but she knows that was nice of them to do, and it was a lot of hassle for them. And so when she pays back, she's not paying back $100,000. She's going to pay $110,000, and probably a whole lot more. Okay, and we'll talk about that here in a second. But let's just, for the sake of this process, in 1 year, she's able to pay it back. $110,000. So what interest rate did she just pay on that thing? 10%. She paid 10% in, and the bank doesn't have this money. The bank has to get this money from someone else. They get it from the public. The public is putting their money in there, and that's how they have this money to even give to Annika in the first place. And so to try to entice you to put your money in the bank, they're going to give you a kickback. They're like, Chris, thank you so much. We couldn't do this without you. Here is some money for letting us do that. So I'm going to give you back $2,000. Okay, so you're going to get back $2,000 on top of what you have. Is that a lot? Yeah. Chris, are you happy with $2,000 free dollars? Yeah, he's pretty happy. That's a pretty good deal. He got 2% interest back. Well, how much did the bank make? $8,000. They made a surplus on that thing. They were making $8,000. Now, sometimes it happens a lot more than that. Okay, but that's the idea. The bank is trying to do this, and it's not just one transaction. It's hundreds of transactions. Okay, and it's not just $10,000 you're getting back. Okay, when you buy a house, I bought my first house. I was able to sign a mortgage for my first house pretty soon after college. Okay, so I did not have a lot of money to put down. I put down like 10,000, maybe 15. I don't remember, something around there. I had to take a mortgage out on my home in Brownsburg. Cost $130,000. Okay, $130,000. I paid $850 a month every month. Okay, I owned my house before I moved. I had it for 10 years. No, 8 years. So I paid $800 a month. It was $850 a month for 8 years, and that was every month. So that's how much money I spent on my house, $81,600. Okay. Do you know how much money I actually paid off of my $130,000 loan? It's like 20 grand. 60 of that grand went just to interest. I didn't actually buy down the house at all. Okay. If I did the math on it, when you get a loan, it's normally a 30-year mortgage. Okay. My $130,000 house, if it would have actually taken me 30 years to buy it off, would have cost me $280,000. So I would have had to pay over twice the house. And that's all because of that interest occurring and keep going and going and going. Okay. So that's how banks make their money, is they're asking you to pay interest. Now I wanted to buy my house. It's better for me than renting because at least I'm getting something back for my money. And so that's why I did that. Okay. But banks are making a good kickback in that as well. Kind of makes sense on how banks make money. Kind of. I know it's not perfect. That is the 20-second or 5-minute high school math teacher version of that. All right, today we're going to do some different formulas. Okay, 2 different formulas we're going to deal with. We're dealing with the compound interest formula. A is equal to P times 1 plus R over N to the NT. The other one we're going to do is the compound continuous formula, otherwise known as the PERT formula. A equals PERT. Okay, they both have different reasons to use them. I am not financially aware enough to know how much each one happens. I would say that this one is happening probably a little bit more often nowadays, but this one can as well in specific bank accounts specifically. Okay, let's talk about the different letters. A stands for the ending amount. How much money do I have in the end? P is going to stand for principal. Anybody know what principal means? My initial. That's my starting amount. Okay, so for Chris, that was his $1 million he put in. He had $1 million principal. He made back $2,000 in the end. R is going to be the rate, and we need to write it as a decimal. So, for example, if I said you something was 5%, what would you actually use? 0.05. What about 7.2%? 0.072. So if it's 7.2%, remember you just move that decimal 1, 2 spots. That's my new number. T is going to stand for time. And 99% of the time when we're dealing with money, we're talking in years. And N is going to be the number of compounds. And that concept alone, I could spend days on just the N part. Okay, I'm going to try to explain it again as quickly as I can, but it's kind of weird. Number of compounds. So understand this situation. Okay, let's say it's January 1st. And I put $1,000 in the bank. Okay, let's say I got a 10% annual interest rate. Okay, so that means every year I'm going to earn 10%. That is not what you're going to get. Anybody know what their bank account gets them? Yeah, I think my Chase account gets me 0.1%, or maybe even it's 0.01%. It's nothing. I make pennies. But the reason I put it in Chase is I have access to it. I can deal with different things, and they give me some things. I don't have to go to the bank to deposit a check and things like that. It's nice. But I don't make any money out of it. That's January 1st. Let's say it's December 31st. 10%, how much am I going to make on December 31st? How much is going to be in my bank account? $1,100. Okay, that is my 10% interest that I earned. That is earning it annually. All year long, it's $1,000. December 31st, now it's $1,100. Okay, that is compounding annually. Well, we could do the same thing, but go semi-annually. What does semi-annually mean, do you think? You're doing it twice a year. So we're earning that same 10%. On January 1st, I got $1,000. On July 1st, I'm going to earn 5%. Because they're going to take my 10% and cut it in half. I'm going to earn 5%. So how much am I going to have in my account on that day? $1,050. I got 5% right here. Well, on December 31st, I'm going to get my other 5%. But the difference is this 5% is of what's in my account right now. And right now I've got 1,050 in there instead of just 1,000. And so you take your 1,050 and I'm going to multiply by 1.05. That's 5%. Ooh, now I have $1,102.50. Let's go. Which would you rather have, more money or less money? I'm going to take the more. It's not a lot, but at least it's something. Okay? That's semi-annually. I could do it quarterly. How often am I doing it if I'm doing it quarterly? 4 times. If I'm doing it semi or monthly, I'm doing it 12 times. Daily? 365. That's nice. Okay? Know that it's not a lot different. Okay? Let's do it quarterly real quick. So I'm taking my $1,000 or daily. I'm going to do $1,000. You don't have to type this in. But it's 1 plus my rate. My rate was 10% divided by my N. And I'm going to raise it to my year, my time times my N. 365. I'd have $1,105. A little better. It's not great. A little better. I'll take a little better. And after a few years, it's going to matter. Then there's something called compounding continuously. Compounding continuously is a little bit easier to calculate because you're not dealing with these weird set times. I would guess that a majority of the accounts are compounded continuously. Okay? So continuous, it's that PERT formula. It's 1,000 E to the R times T. Oh, look, I made 2 more cents. So it's not a lot more, but again, it's a little bit more. It's constantly calculating. Okay, so there's the different setups. Let's do it. Finding the amount that results from each investment. I have $800. It's invested at 5% compounded daily after a period of 4 years. So the first thing we have to do is decide which equation. What was that? Are we all right? Which equation am I picking here? Am I picking the first one or the second one? First one. And the reason I'm picking the first one is because it says compounded daily. If they tell you how often you're compounding, you're using the first one. If they say continuous, we use the second. All right, so I'm using this formula. I'm going to label some stuff. $800. What's that 800 going to be for us? That's my principal. 800 is P. My rate is going to be 0.05. And my N is 365 because it's daily. And my T is 4. So once I've found those things, it is a button push. Get out your calculator and button push and see what you can do with it. So I'll just type it in. We take that whole thing, we type it in. We're getting 5% interest. That's really good. Okay? If you find a bank that gets you 5% interest, take it right now. Okay? It's hard to find. $977. We are going to round for money's sake today to 2 decimals. So $977.11. So after 4 years of investing that money, I basically made a free $177. Yes, sir. We are going to. I don't know. To be honest, I don't run a bank, so I don't know how that works. I don't know if they round up or round down. I'm guessing they probably don't round up. We're going to round. They do? We're going to round to the nearest number. We're just rounding the nearest whole number. I'm not sure how banks work. Next one. As we read that second one, $1,250 and invested at 8.6, compounded continuously. So which formula we're using, first or second? Second, you are using PERT formula. A equals P-E-R-T. Go ahead and calculate that without me. We want that time to be in terms of years. So if they say 2 years and 3 months, what's my time going to be? 2.25. Because 3 months is a quarter of a year. So 2.25. .086, correct? Okay, I just couldn't remember. Times 2.25 years. We're just typing it in. Our principal, E to our rate times time. We hit enter. 1516.86. $1,516.86. Once you set it up, once you know how to do it, it's just button pushing. Questions on B? Letter C says to find the principal needed to get each amount. We are trying to get $1,000 after 2.5 years compounded continuously. So if I'm compounding continuously, I'm using this formula right here. What is that $1,000 going to be for us? That's our A. We're trying to get that amount. That's our ending amount. So that's going to be 1,000. I'm trying to figure out what principal is. That's P. E. My R is going to be 0.13. And my T is going to be time, 2.5. So how do I solve for P? I want to get P by itself. What in general, what is that thing? It's just a number. There's no variables. It's P times that. So if I want to solve, all I need to do is divide by E to the 0.13 times 2.5. So in my calculator, I'm taking 1,000 divided by E to the 0.13 times 2.5. Yeah. Hit enter. $722.53. And that should make some sense. All right. In 2.5 years, that's a good amount. You're making a good deal there, almost $300 in just 2.5 years. Now, again, that's because you're earning 13%. You're not actually going to get that. Okay, you're going to get in the 1 to 2% range at a good loan. Anybody ever heard of CDs before? Yeah. Bank CDs or bonds? Ever heard of buying bonds? Yeah. Those concepts for both of those things. So what they have, if you ever go into a bank and you walk in, on the front banister, they'll talk about CDs. And so like it'll say CDs, and I think it's like a certified deposit. I don't remember what the C stands for. I apologize. But those are going to be like 5-year CDs or 10-year CDs. When you buy them, basically you're saying, I'm going to give you my money for 5 to 10 years, and I'm not going to touch it. Okay, same thing is true with bonds. Bonds take longer. But basically for 10 years, you're going to invest money like $1,000. And you're saying for 10 years, I don't need it at all. I'm not going to touch it. If I take it out early, you don't have to give me anything extra on it. But if I wait 10 years before I turn it in, I'm going to give you a better interest rate because you're saying it's guaranteed that you keep that money. And so instead of like a 1%, you can get like a 3 or 4 or maybe even a 5% on a CD. So that's how you kind of get the better things. You ever heard of 401ks? That's the ultimate CD, basically. You're putting your money into a retirement account. And that retirement account, you're saying, I'm not touching that probably until I'm 65 years old. And because of that, you're going to gain a lot better interest rate on your investment. Yes, sir? Can you add more to a 401k? Yeah, I'm not positive on a CD, but a 401k is constantly growing. Okay, and we'll kind of talk about that on the next one. But the more you put in early, that's the longer amount of time the interest has to build, and it's going to be a lot better for you. Okay, let's flip to the backside. Time required to double or triple an investment. How long will it take for an investment to double if its value if it earns 5% compounded continuously? Okay, so compound continuous, boom. We know we're going to this formula right here. 5%. All right, cool. That's my interest rate. So 0.05. What am I searching for in the end here? T. Yeah, how long? So I'm looking for T. They didn't give me A or P. Alex? Yeah, you get to make it up. So pick any number you want for your principal because it just says an investment. I don't care what the investment is. Pick a number. I'd pick an easy one. Let's start with $1 in the bank account. If I'm doubling it, how much money am I going to have? $2. Now, you could pick any number you want. 1 and 2 isn't very exciting. In your mind, imagine that's 1 million and 2 million. But it's all the same, okay? Because the first thing you're going to do is divide, and you're going to get 2. No matter what 2 numbers in there, you're going to get 2. To me, I'm just not even going to put a 1 there because it's 1. Okay? So we're going to solve. What do I need to solve for T? What do I have to do here? I'm going to take the natural log of both sides because it's e to that power. If I take the natural log of e, that's going to cancel out. So I get the natural log of 2 is equal to 0.05t. So in my calculator, I'm taking the natural log of 2, and I need to divide by 0.05. I get $13.80. I'm sorry, not $13. That is 13.863 years to make $1. Or if I would have put $1 million in, it would have made me a whole $1 million. I would have $2 million now. If in 13 years you said you doubled some money, yeah, I'll take that. I'd rather it be sooner, but I guess we'll deal with it. So that was 13 years. How long would it take you to triple your money? Take a second real quick and figure out how long does it take you to triple. It should be a pretty quick computation once you get the hang of it. Basically, all you got to do is take the natural log of 3 instead of 2. How long did it take us to triple our money? 21 round it. Is it 21 up? Does it round up or down? Up, so 22 years. All right. What about quadruple your money? How long is it going to take you to quadruple your money? So again, we're taking the natural log of 4 divided by 0.05. 28 years. What about quintuple your money? It is getting out of hand, but quintuple is a fun word. We don't use it enough. 32 years. So know what we started with? We started with $1 million. It took us 13 years, almost 14 years to double it. Then it only took us 8 more years to triple it. Then it only took us 6 more years to quadruple. Then it's getting 4 years. And what about sextuple or even more, to 10 times the amount of money? What's happening each time? It's getting smaller. We're able to go faster and understand why. This is exponential growth. Okay? You're starting here, you're starting slow, and then you are taking off. And so while it might take you longer to double, to triple, it's faster. And then to quadruple, it's even quicker. These X values are coming faster as we go down the line. And it's going to keep growing and growing and growing. That's why the more money you save now, the longer it's in the bank, the more money you're going to get because that interest rate starts to grow. Okay? 5% is not a ridiculous amount. Okay? If I let that sit for 50 years, how much money do you have right now that you could put away? Let's say you have $500. You have a nice relative that gives you $500. Okay? And you're 18 years old. Let's say you want to get that money out when you're 68. So 50 years from now, you're just going to put away $500 right now. Sure, it'd be something nice. But let's say we put $500 away at 0.05. We're going to multiply that by 50 years. How much money do you think that $500 is going to become? $6,000. It's pretty good. And that's only at 5%. You probably can get 5%. Okay, and that was only $500. Well, what if, let's say you had a couple grand. Okay, 2,000. Well, now in 50 years, that 2,000 to 24,000 and more. Okay, if you could put away a couple $100 every year, then all of a sudden that's going to grow. And that's why people can retire. Because when you put money away and you let it to keep grow and you keep putting a little bit more away each year, that interest is going to grow and grow and grow. And that's what a 401k is all about, is putting away that money and keeping it put away for long enough that with interest rate, it's going to grow.